Welcome learners. Welcome to this session on Relational Database Management System. My name is Ashish Jain. I'm an assistant professor at the Department of Computer Applications at the Bhopal School of Social Sciences. Let's begin this module. This is a brief outline of this module. We will start with the introduction to a concept called data model. We will see different types of data models, how we classify different data models. We will see some data models like hierarchical data model and network data model in this module. So let's begin our session. Data model. Data model is a conceptual tool. It is used for describing the design of the database. Here it is important to understand the concept of design. In DBMS terms, we say design as a schema. So it generally defines the structure or the design of the database at different levels. In the previous modules, I have described about different levels of architecture in DBMS. So we have a conceptual level DBMS, we have a logical level DBMS, and we have a physical level DBMS. So at all these levels, we have to define the structure of database. For that, we require different data models. So we have a conceptual model, we have a logical model, and we have a physical data model. The term data model defines how the logical structure of DBMS or database is modeled. It is defined as an abstract model that organizes the data description, data semantics, and consistency constraints of data. What does this paragraph means is that we use data models to define how we model our data so that it can be easily understood and representable in a DBMS setup. Here, the organization of data, that means the description of various columns it has, then various logics or semantics, as well as consistency constraints to ensure that we have a consistent and proper data are all modeled using a data model tool. It emphasizes on what data is needed and how it should be organized instead of concerning on what operations will be performed. That means the operations that are performed on data are separated on how data is actually represented. Let us now look at the different data modeling tasks we have. We start with the business analysis at the conceptual level. At the logical level, we have the logical design of the data model or database design. And finally, at the physical level, we have the database design, or we can say that performance design, wherein actual implementation of database takes place. Let us see some importance of the data models we have. The term data model simply defines the simple representation of complex real-world data structures that are useful for supporting a specific problem domain. How we represent the real-world objects using a database are defined in data models. And we can say that data modeling is a process of creating a visual representation. This is a logical representation, not the physical one. So it creates a visual representation of either a whole information or in parts we can represent information, and we should have connections between various data points as well as the different data structures. And it is also an iterative and progressive process. That means we move on in steps, in iterations, and we progress from one stage to the other. Here we see that the importance of data model is that it provides a communication tool. Since we represent information and we can understand the relationship among different data, so it is a good communication tool to convey the information. Secondly, data models give an overall view of the database. Just by seeing the visual representation, we can have an idea of how database is organized and how our data is related and stored together. Data models organize the data for various users. Depending upon the level of users we have, we can organize our data in a better manner using different data models. And also, it provides an abstraction for the creation of good database. What is an abstraction? To give away only the detailed information and hide all the technical or the non-required details. This is called abstraction. Since we are using 3-level architecture in DBMS, this is how we implement different levels of abstraction here. In 1970s, we have a relational data model in which we represent data in terms of tables, and we have SQL language to query the database for the retrieval of information. Then we have entity relationship model. It gives a better understanding about the logic behind organizing the data, but this is limited to only representation, not the actual implementation. Then we have semantic models. In it, we have the object-oriented model, as well as we have extended relational models. So here, they give more semantics in data models. They support more complex objects. They allow to use the properties of object-oriented programming, like we have inheritance, so that we can inherit certain properties. It becomes very easy. And then we can use XML data exchanges and unstructured data also. Previously we have to have proper structure in the database, but later on, as we have unstructured data also, so this type of representation provides a means to model unstructured database. Then as the demand for data as well as the amount of data increase, there is a requirement to have a proper mechanism to store this huge amount of data. This is called big data, and for this we require NoSQL data model, right? Let us see some types of data models. So we have at the conceptual level, we have the ER model, we have the object-based data model. At the representation data model level, we have the relational model, the hierarchical model, the network model, and at the physical or the lowest level, we have the index model. This conceptual database models, they are also referred as domain model because they are domain centric or domain specific models, right? These models are usually created as a part of the process of gathering the initial project requirements. Suppose we are having time, product, sales and stores, these four files, and there is a link or association among the values. So we just basically write down the basic structure of all these tables or all these structures, and we have to have some connections between them. Such organization is very basic, and this is called conceptual level, just to have an understandability that how things are organized. But actually this is a logical representation. The physical representation of all these is different because ultimately the data is stored in the disks, and the representation of data in the disk is different from what we represented. Now we come to the logical data model. Here in logical data model, they are less abstract and provide a very greater detail about the concepts and the relationships in the domain under consideration. What are domains? Domains are set of allowed values we have. So, and they can follow several formal data modeling notations. We have different notations of representing various types like data attributes and other types relation to data. So it helps you to properly express all these factors. And these models is useful in highly procedural implementation environments for the projects that are very data oriented, like data warehousing, reporting, etc. Here, if you see in the previous example, we have seen that only we define the structures. Here we also define some other details regarding to this particular structure. For example, we have for time, we have the values as date description, month description, and so on. For the product, in product table, we have these many details. In other two tables, we also have other details. So this is a more detailed description of the previous one. Now we come to the physical data model. They provide a schema means design, for how the data will be physically stored within a database. They offer a finalized design that can be implemented as a relational database with specific properties, including the performance tunings and all. And we can have different representations here. We can represent relational data objects like tables, columns, primary and foreign keys, etc. Also their relationships. But this is separate from the logical representation. Here we have like the tables, and it contains the information about different column types or field types. That means date type field is an integer field, date is a varchar. It is the data type of the different data. So it gives much more details about how you represent the things. Now the building blocks of the data models. The first concept is entity. What is an entity? Entity is any unique and distinct object used to collect and store data. For example, we want to store data about a student. So how we collect data? We collect information regarding to student like student's roll number, name, father's name, address, class, percentage, and so on. So all this together will constitute information about one particular thing, and that thing is our student. So we will consider student as an entity. Entity is always having a real world existence. Then attribute. The characteristics of entity, all those features by which we identify an entity, forms a part of attribute. So all these values like roll number, name, class, address, etc. regarding to a particular entity student are called the attributes of this entity student. Then we have relationship. Why we are maintaining entities? So that we can have some kind of relationship among different entities so that we have a connected database together. So it is an association among entities. We can have majorly these three types of associations: one to many, many to many, and one to one association. Then apart from this, we also have some kind of constraints that are set of rules to ensure that we have an integrated data. For example, age field. We can restrict that the age of an employee should not be less than 18 years and should not be more than 30 years while joining, right? So we can define the set of constraints here. There are so many things that we can put on as a constraint so that we have the correct data in our database. Then how we construct the data models. There are two methods. First is two steps. First is identifying and documenting the business rules, and secondly, translating those business rules into data model components. How do we do that? Here, identifying and documenting the business rules helps to first standardize the company's view of data, how data is perceived by the company, how they are going to use it. First, we will analyze this. Then, how communication will take place among the user and designer. This is very important so that users, the ultimate users of those products, can brief the designers what they want. It also allows the designers to first understand the nature, the role, the scope of data, and also the various business processes that are required to be managed. It also helps to develop appropriate relationship participation rules and constraints based upon the requirements, and finally create an accurate data model so that what all requirements are as per the company, they are fulfilling all these. Then once we have all the business rules defined and documented, now it's a time to translate all these rules into data model components. How? Here, all the nouns are translated into entities. For example, employee, managers, customers, right? So vendors, all these are nouns. So they are translated into entities in DBMS. Then we have verbs. All the verbs are translated into relationship. For example, employee works in a department. This works is a verb. So this works, that thing becomes a part of relationship. A student enrolls for a course. This enrolled is a verb in specification of business rules. We will convert this into a kind of a relationship. Then all the relationships are bidirectional. That means if you are having a relationship between two different tables, then we can say that one instance of first table is also related to second or instance of second table, and vice versa. So we have a relationship that is bidirectional. That means from one table to the other and back from the other table to the previous table. Now we first look at hierarchical data model. What is hierarchical data model? This was the first data model which is developed in around 1960s by IBM, and it organizes data in a tree-like hierarchical structure. That is why it is called hierarchical data model, and it is very well used in XML systems and geographic information systems like GIS. So this is an example. So we have shoes. Shoes can be women's shoes or men's shoes. Women's shoes again have further classifications as high heels or bellies. In men's shoes, we have sports shoes and sneakers. So this is a hierarchical relationship. This kind of relationship is represented using hierarchical data model. These are the basic features. It contains nodes which are connected by branches. If you are aware of the data structure, this is a tree-like structure. So here this thing is known as a node, and the first node is called the root node. This is the root node, and these are actually the children of this root node. So this is a parent and this is the children. So we have a parent-child relationship among the values here. Each node has exactly one parent. So this node has one parent, this node has one parent. Every node has one parent except the leaf node. These are called the leaf nodes. And one parent may have many children. So this parent has two child, this parent also has two child, they don't have any child. This is another example, an employee. Employee can be an intern, a contract employee, or a permanent. Permanent employee can be a manager or a software engineer. So such associations can be represented or modeled using hierarchical model. These are the advantages of hierarchical model. So there is a parent-child relationship due to which its concepts are very simple to understand. It promotes sharing of data. For example, an employee has an employee name, employee ID, and some other features. Intern also has these features, but instead of keeping them here separately, what we are doing, we are using the concept of inheritance. We are using the concept of hierarchy so that we can have these features here as well apart from its own features. So it provides security of data and it takes one-to-many relationships. One can have many relationships. Disadvantages: it is not very flexible. It does not have data definition, data manipulation languages. So to define the data at particular level is tough, and also to do any kind of manipulation. It requires knowledge of physical storage for complex implementation. As this is a logical representation, to have a physical representation and to have a link between them, this is a hard task. It's very complex, and the changes in a structure requires that all the program should be updated so that all the changes are visible everywhere. To overcome the difficulties of hierarchical network, we have network data model. In network data model, it is same as hierarchical, but instead of a tree-like structure, we use a graph. So instead of tree, it focuses on using the graph. What is graph? That is, it has a circle, a cycle in it. That is, you have more than one path to reach a particular node. Here, student, I can reach college to CSE department and student, or else I can go from college to library, library to student. So there are more than one path from one node to the other. This kind of arrangement is called a graph. And to organize data, it uses directed graph. What is directed graph? We have arrows. That means we can go from this to this, but we cannot come back. If there is no arrow, it can be bidirectional. But if we are moving from college to this library, it doesn't mean that there is a link between library to college. That's why we have an arrow from college to library. So this is called a directed graph. Let us take another example. We have a store. A store can have customers, manager, and salesmen. Customers can place order. Manager can also place order. Salesman can also place order. Salesman is connected to items and orders. Customer can place orders. So this is a kind of association. Here if you see, we have more than one parent to a particular node. Here order have customer, manager and salesman. So if you allow more than one parent, this is called a network model. This is also a hierarchical kind of structure. But instead of tree, it uses graph. These are the advantages. Its concept is as simple as hierarchical model because it's very simple to understand. There is more than one parent-child association. That means for one child, there can be more than one parents here. Data can be accessed easily in it. Since we have multiple paths to access a node, if you cannot access it from one way, you can always go from other. It provides integrity of data, and it contains a data definition as well as data manipulation language here, so that you can define and change the data very easily. Now we see disadvantage of network model. The data structure is very complex. Since we have to maintain the data structure for different parents and their other associations, so it is a very complex task to maintain. Any change like updation, deletion, insertion is very complex because you have to make changes a lot many places, and changes in its structure require changes in all the programs wherever it is used. Let us see and look back and what we have covered in this module. We started with the concept of data models. We have seen that it is a logical representation of data. We have defined data models on three levels, like conceptual level, the logical level as external conceptual, and the physical level. Then we have seen the importance of data model. We have seen how data models are classified into hierarchical, network, relation and other data models. And in this module, we have covered two types of data models. That is, first is the hierarchical model and second is the network model. In the subsequent modules, we will be covering different types of data models also. In this, we have covered these two data models. I hope this session is beneficial for you. Thank you. Happy learning.